Today I'm going to talk about affirmative action policy used in India in technical colleges. According to this affirmative action policy, for each institution, some of the available seats are reserved for uh, some groups of students subject to affirmative action. And you can see percentages of seats reserved for those categories. And half of the available seats are considered as open category positions, and these positions are open for everyone. Everyone can get a seat from that category. And getting a seat from reserve category, students they must be eligible to that relevant reserve category, and they must declare that they are member of that category. Okay, we can pass. We built our model as a matching problem, and we followed Baswana et al. 2018 paper. And in this matching problem, we have set of individuals, they are strategic agents, and a set of institutions. And for each institution, we have a vector of number of positions for categories. Uh, for open categories, scheduled castes, scheduled tribes, and other backward classes categories. So for student side, for agent side, PI is the strict preferences of students over institutions. And for institution side, we define a choice rule which specifies how institutions choose students from application pool. And to define that choice rule, we need to follow legal requirements. We need to comply with legal requirements. And those legal requirements, the first one, for each category and in all institutions, merit scores must be respected. Higher ranked students must get higher priority. Second one, open category positions, they must filled before reserve category positions. So if a student has a high score, even when that student is eligible for reserve category, if that student is also eligible for open category, student must get open category seat instead of reserve category. Okay, so we fill those seats beforehand. Next, if due to lack of demand, SC and ST category positions are vacant, then we do not reallocate those positions. On the other hand, for OBC positions, uh, we need to reallocate them, and we must turn them into open category positions. But law or legal documents, they do not specify how we should run this re dereservation process. Okay. Uh, Among those four requirements, legal requirements 1 and 2 uniquely defines this choice rule. We call it reserve choice function. And for any set of applicants, institution fills open category positions first and chooses agents one by one according to their merit score. And then for each reserve category, institution considers only students eligible for those reserve category positions, and again accepts them one by one according to their merit scores. So here we don't have any dereservation policy yet. So in this matching problem, we have student institutions and choice rules and preferences. And the outcome of this matching problem will be an assignment. An assignment does not only specify name of student and name of the institution, but also it specifies what kind of seat, what kind of position that student received at the end. General category student only can get open category seat, but reserve category students, they can get either open seat or some reserve category position. And for any problem, we run a matching mechanism to construct an assignment. And to run this matching mechanism, students, the strategic part, they submit their preferences over institutions along with their declaration for reserve membership. As I said before, a declaration of eligibility is optional. And a mechanism is incentive compatible if for any student submitting actual preference over institutions along with declaring all reserve memberships, eligible reserve memberships, must be weekly dominant strategy. Okay, so how do we construct an outcome here? The the best way we have is using deferred acceptance algorithm, student proposed deferred acceptance algorithm, of course. Uh, if we have no reallocation or de-reservation policy, then the problem is solved. But as you may remember from the fourth legal requirement, unused OBC seats must be turned to open seats. And Baswana et al. Solved this problem by rerunning deferred acceptance algorithm. Okay, and for at the end of the deferred acceptance algorithm, of course, for some institutions, some OBC seats may be unfilled. Okay, and at the end of the DA, they iterate deferred acceptance again by updating number of available positions, and they add number of unfilled OBC seats to number of open category positions. And they keep running this deferred acceptance algorithm again and again by updating those vector of available seats until there is no unused OBC seat left in any institution. Okay, we have this example of multi-run DA. So for simplicity, let's say we have just one institution and 10 individuals applying to that institution S. The second column shows their category membership. GC means general category, OBC, SC, and ST categories. And as you can see from the third column, individual I1 has the highest score, highest ranking, and I10 has the lowest score. Okay, so how this mechanism works as the following. Initially, we have 5 seats for open category, 1 seats each for SC and ST, and 3 seats for OBC. And first, we fill open seats, and first 5 students, they get those open category positions. Then we fill SC and ST, and I7 and I10 gets those seats. And we have 3 available seats for OBC, but we have only 1 OBC student, and they get that student gets that remaining that 1 seat and 2 seats remain empty. And in the first iteration, those two unfilled seats are added to open category positions. And as you see, the OBC student is the sixth best student. And in the first iteration, that student will receive open category. So there will be no student left for OBC seat, and that seat will stay empty at the end of first iteration. And in the second iteration, that remaining one OBC seat is added to open category. And in the second iteration, we have eight positions for open category students. So in the last iteration, we have 8, 1, 1, and 0 positions for those categories. Okay, so we analyze this mechanism, and there are some problems with the mechanism we observe. The first one is about incentive compatibility, right? For incentive compatibility, agents, we want agents to submit their actual preferences and actual category membership. But as you see here, multi-run DA is manipulable via preference misreporting. And it is also manipulable by not reporting category membership. So incentive compatibility is violated by these two dimensions. Okay, so to overcome this problem and to improve welfare of agents, we introduced backward transfer choice rule. So we actually mimic multi-run DA mechanism, but we run those iterations in the choice function level rather than running mechanism again and again. Okay. So what we do, for any application pool, we run the reserve choice function, and we add unfilled OBC seats to open category positions. But as I said, we do those iterations in choice function level. Then we run deferred acceptance algorithm. Okay. So the good thing about this choice rule is that this choice rule comply with the spirit of affirmative action, which means declaring reserve category membership always makes agents weakly better off. It's always better for students. So misleading by not declaring category membership is not going to happen here. And also, deferred acceptance algorithm induced by backward transfer choice rule, Pareto dominates multi-run DA mechanism. And not only that, in the next slide, we also show that this DABT mechanism comply with all those legal requirements, and along with incentive compatibility, we can characterize the DABT mechanism. Okay, so the DABT mechanism is the only mechanism satisfying individual rationality, meritocracy, non-wastefulness for positions, open first, as I said, one of the legal requirements, and incentive compatibility. So by those five properties, by those five axes, we can characterize the EBT mechanism. So as you see here, we studied joint implementation of reservation along with dereservation policies in affirmative action in India. and we analyzed the current mechanism and introduced backward transfer choice rule and proposed the DABT mechanism. And by characterization result, we showed that DABT is the unique mechanism satisfying legal requirements while improving welfare of agents. Thanks for listening.
Thank you, Orhan. Maybe we can have one very short question, but we are already a little bit over time because of the early connection issues. If not, please contact Orhan via the chat or on Gather. Thank you.
Sorry about those technical problems.
Okay.
All right.
So thank you, Orhan, again. I'll hand over to Mohammed for the remaining speakers.